Now we come to the basic proportionality theorem and its proof. Okay, so the theorem says, okay, if a line is drawn parallel to one side of a triangle, to cut the other two sides in distinct points, then the other two sides are divided in then the other two sides are divided in the same ratio. Okay. Okay. Then the other two sides are divided in the same ratio. So it wants to say this, that if there is a triangle like this, okay, if there is a triangle like this and you draw a line parallel to say I name this triangle ABC, and I draw a line parallel to BC, say anywhere, let us say here, okay, let's say here, let be parallel, and it cuts it in D and E. Okay, then we want to prove that. So if a line is drawn parallel to one side of a triangle to cut the other two sides in distinct points, so this is that line D that is drawn parallel to BC to cut it in two distinct points D and E, then the other two sides are divided in the same ratio. So these two sides which it has cut, they are divided in the same ratio. That means to prove AD upon DB is equal to AE upon EC. This is what we are supposed to prove. Okay. Now we'll do some construction for that. Okay. We'll do some construction for that. First of all, we'll join these. Okay. We'll join these. So construction is join D to C and join D to C, B to E. Okay, so you also join this. Okay, I join this. Now what? I also do two things. I draw from D and E onto their opposite sides to altitudes. Okay, so we draw DM perpendicular to AC. So draw DM perpendicular to AC, and also So EN perpendicular to AB and EN perpendicular to AB. Okay, we get the point. We draw EN perpendicular to AB and DM perpendicular to AC. Okay, we get that point. Now we find out the area of the triangle ADE. What is the we are doing the proof now. The area of the triangle ADE is obviously half base into height. Okay, half base into height. Now what is that? That can be said to be, if we take this to be the base, this is half AD into EN, is it not? So that is the area of the triangle, correct? AD into EN. So this is 1. Also area of triangle ADE. Now this time I take the base to be this, the same triangle, but base is AE, so it is half base, that is AE, into the altitude, that is DM. So both of them will be the area of the same triangle, and since they are the same triangle, the area has to be equal. So this expression, they are the same. Correct? These two expressions are the same. Correct? Now you talk about the triangle CDE and BED. Okay, let's talk about the triangles CDE and triangle BDE. What are they? They are between the same parallels, okay, and are on the same base DE. Okay, are on the same base DE, parallels, and between the same parallels DE and BC. They are between the same parallels and are on the same base. Hence, their areas are equal. Okay? Hence, their areas are equal on the same base and between the same parallels. Okay? Now let us try to find out their areas. Okay, so area of triangle CDE. See, the triangle is CDE, I take this as base, okay. So the altitude becomes, on this extended base there is this altitude from D, that means DM is the altitude. Do we understand?
Yes.
We are taking this triangle, see this triangle, I'll draw it in different color, maybe red, okay. So we are talking about this triangle,
DBC.
no, DEC, this triangle, the red triangle, okay. Now if you extend this side, actually this DM becomes the corresponding altitude, right? So it is, so if the base is CE, then the altitude is DM is equal to half into CE into DM. This I mark as third. And area of triangle BDE, area of triangle BDE is half, okay. BDE is half BD into half BDC. Now forget this triangle, I convert it back into the green, into blue, okay. Forget this triangle, okay. Now we concentrate on BDE. So this is my new triangle, okay. This, okay, and this. Now you see, I have extended the side. If I am taking base as BD, on the extended side I have EN as the altitude. So half into BD into EN, okay. So is that. This is the fourth equation, okay. Now what happens? See, if I take the ratio of ADE and CDE, now area, I'll do it from here, area of triangle ADE upon area of triangle CDE is the same as area of the triangle ADE upon area of the triangle BDE, area of triangle BDE. They should be equal. Why? Since area of triangle CDE is equal to area of triangle BDE. Correct? Now here I put 1. Okay, here I put this. So I say half AD into EN divided by half CD is half CE into DM or I'll put triangle BDE here, okay. I'll put triangle BDE here and CDE here. One and the same thing, even if we had not put them as the same. So BD is BD into EN, BD into EN, okay. BD into EN, and this is equal to half AE into DN, while here it is half CE into DM. What happens? EN cuts, DM cuts, okay. AD upon BD is equal to AE upon CE, which we can say is AD upon DB is equal to AE upon, and this is what we were supposed to prove. So whenever it cuts in, whenever a line is parallel, okay, whenever line is parallel to one of the sides and it cuts the other two sides into distinct points, then what happens? The ratios of the sides in which it cuts it remains the same. It remains the same. Fine. That is the BPT and its proof for us. It's an important theorem. Its proof is also asked as a theorem and also as a proof. Okay, you will be required to prove it. Okay.